So, hi, this project is related to design and implementation of UEFI compliant bootloader for the legacy system moderation. Basically, this is the system development structure of operating system. We called it, this is a Windows subsystem, and we just designed this Windows structure system for the development of the testing of new implementation, new complement bootloader of to develop the incompatible with modern firmware standards basically. So the thing is that this that's why our primary objective to create the robust bootloader that seamlessly loads and executes the kernel images from the predefined disk sectors without relying on a file system or user interaction boot menu. So basically this solves the interaction of different uh, strict, disk structure. The bootloader was architected in two phases, like in initial UEFI applications that handles the firmware interactions, and the second stage is basically responsible for the reading boot parameters, identifying the target kernel with the initiating its execution. The final implementation basically supports a multi-operating system environment capable of loading Windows, PE32 plus Linux and everything as well. Okay, so in the operating system, in this operating system, it supports the Linux, Windows, with the Mac, with the 64-bit as well as the 32-bit as well. Okay, so it this complete bootloader operates fully integrates in UEFI runtime services to access the system memory map with ACPI tables, as well as this bootloader successfully tested in both virtualized and physical UEFI environments, demonstrating the reliable operation, rapid boot times, as well as the minimal disk footprint. Okay, so I have added the complete abstract with the introduction, like how we can use the BIOS system in which input and output system with boot record system, partition scheme, as well as the standard and initializing the hardware with loading and operating system. And BIOS basically used to significant normally BIOS suffer from different significant limitations, for example, including a 16-bit processor mode, 1 MB addressable memory space, and a lack of standardized extensible interface for the pre-boot applications. So that's why the UEFI, like the Unified Extensible Firmware interface, was developed to address these shortcomings, offerings and a modern 32 or 64-bit environment structure protocol system, and it also supports for large disks via a guide partition table basically. Okay, so this is a figure which explains like how UEFI and PI specifies the standardized path for the development of UEFI conformant firmware and its extension basically. Okay, so the next part is this project was initiated to address the UEFI firmware. A direct port was infeasible due to fundamental architecture differences, and next part is basically conceptual view of the UEFI conformant system for booting and operating system. And next one is I have just added the literature review and technical background. UEFI, its architecture and comparison of executable formats, ACPI and memory chips maps. So I have just explained everything in this section, like what design methodology I have used, how we can adjust the disk layout constraints, and the area, boot area, system storage area, images area, as well as the reserved and general storage areas through bootloader architecture. It also contains the two stage design. One is boot phase, which contains initialization, load boot phase, handoff, and second one is boot phase 2, which is basically core bootloader logic, which contains a parameter parsing, kernel identification, kernel loading, image parsing and relocation, system information gathering, and the finalize the kernel handoff. Okay. So the implementation and development phase contains the complete structure and explanation, like what program I have used, like C program I have used different blocks with the media storage system. So yes, this is the overview, like main menu of UEFI complaint bootloader, which contains, you can just adjust through the press. It also a user-friendly structure, which provide us the complete structure of how it provide us the complete guidelines to the users, like how you can perform through UEFI bootloader in your system to improve its efficiency. Like see this, right? Press B for boot menu, press S for setup, press escape for shutdown and everything. Okay. So this is the setup menu of bootloader, which is provided for the UEFI system. Okay. And the testing and validation, we have just tested this complete structure on the Windows, Linux, and Mac operating system, which is perfectly developed and perfectly worked. So this is basically the overview, final testing and technical specification of firmware architecture of UEFI system. So yes, basically in the complete system, let me finalize our conclusion is that we have just tested the complete UEFI complete in different architectures, in different systems with different, like 32-bit and 64-bit, with different operating system environments as well. Okay. So these are future work and references are added. This is the program files are added in it. All the codes and added in it. You just read it, the source code, and you will get the output results. Okay. This is a complete structure of UEFI loader. Okay. All the C files with the structure of firmware is added here. Okay. I will add this into the project files with the article support as well. Okay. Thank you.